been working on a project for the charity that I work for, which is called REMAP. I don't know if you want to know more about REMAP, go and just Google it. But we make things for people who have disabilities. That's the real top and tail of it. So I've been working on a project for a guy who has is severely visually impaired. He has a condition which means that he can't. It's his optic nerve that's the problem, not his actual eyes themselves. The eyes can see, but the information doesn't get through very well. So he can only see really bright, contrasty things. He can read on a computer screen. He has to have his font about that big in order to read it, black on, white on black. So it's really, really contrasting. He enjoys football, and one of the problems is when he goes to the football, he can't really see the players. He just can hear what's going on, and I think he listens to the radio sometimes at the same for the commentary and everything. So he had a friend of his took a camera to the game once or twice and tried to video it, and he tried to watch it on a tablet, but it was not terribly successful because of the technology isn't really suitable for doing that. It didn't work out terribly well, but initially, it was better than not being able to see anything, because he could hold the tablet really. He can see if he holds things really close. So I talked to him and I said, look, we can do something about this. And what I've done is I've modified a VR headset. This is a fairly cheap VR headset, and I've mounted a LCD display onto the front of it rather than using a mobile phone, which is what they're normally designed to do. So this neat HDMI video goes onto this screen here. In order for the camera itself, obviously has to be self-operated because it's too difficult to have somebody there all the time. So what we've got is a camera that mounts on the front in this box. Actually, it's upside down. It goes on that way. So but effectively in the middle here there is a camera, which is a Logitech webcam. Now I've had to modify the webcam by putting a CCTV lens on it, because you need some form of zoom in order to get in a bit closer to the action, because the standard lens on a webcam is designed for you to sit really closely. It's a bit like this thing that we're using here, this GoPro. So they're very wide angle, not suitable for watching football matches. So I've put this lens on here, which is a 7 to 22 millimeter surveillance type lens, which will allow him to get a lot closer. In fact, 22 millimeters is going to be pretty powerful on the size of CCD chip that's in here. But this is a 1080p camera. It's a good quality camera. What I'm doing is that's been streamed over USB and also down the same cable, and that's what all these other electronics are for, the USB and the CCTV, the camera control lens and such like. And they go back to a central box, and this is the central box here. And inside there, let me just show you quickly what's inside here. Inside here, the brains of the operation is this here, which is a Raspberry Pi 3. These are actually pretty capable little computers, and although it's not quite as fast as the laptop which I prototyped this originally on, it is still pretty good, and it's almost real-time video coming from the camera and being displayed onto the LCD display. I think there's only about a couple of hundred milliseconds of delay, which is pretty impressive. The whole thing is powered. It's got a battery backup system for the Raspberry Pi, so you can switch it on and off just with a switch, so it doesn't have to do anything complicated. The whole thing's powered by a graphene battery, which is the latest technology used for ROVs. Super light, 5.2 amp hours is that battery there, and it weighs almost nothing. Unfortunately, it has to have some fancy charging, so there's a fancy. So basically, the lithium polymer. Sorry about this, guys. The washing machine has decided it's going to go onto spin cycle. I have to share my workshop with a washing machine, and it's annoying. This is basically this graphene battery is lithium polymer chemistry, effectively, with graphene internals. So you have to charge it with suitable smart charger, which is what this is here. Now today's task is to finish off mounting all the electronics in here. Some of the boards, I've already made a mount here for the lens and the camera. I've got to make some more mounting hardware to get this lot in, to fix it into the box, and then it gets screwed on. and then all we've got to do is finish off the software. The software running on the Raspberry Pi is all written by me as well, which is all written in Python using open source video processing libraries, which I'll do a video on the software side as well. So let's get cracking. We've got some basically some machining some plastic holders for these boards, and then we've just got to neaten up the wires, and hopefully we should later today get the thing cranked up and working. The headset itself, I showed you this very briefly when it was in bits. It's now all together. I'm not going to take it apart again to show you, so sorry. But effectively, there's the VR headset with an LCD screen, as we pointed out before. Now the camera and the lens controller and all the power system is all in here. So the camera is USB. The USB is on this connection here. I must make a strain relief for that. Unfortunately, some of the wiring is still outside of the box. It was just too difficult to integrate. But this wire takes the USB down into the Raspberry Pi box, which is actually down in its bag. I'll show you that maybe. I think I've already showed you the internals of that, but it's now fitted into a bag. And then it gets processed by the Raspberry Pi, and then it comes back up this HDMI cable and back onto the screen on here. Now I'm running on the Raspberry Pi. I'm able to run VNC, which allows me to see what's going on the laptop, as well as obviously if you look inside here, which I don't think it'll work very well if I show you what's going on in there. It's really designed obviously to wear on your face, but I can show you on the screen what's actually going on. So if I just put the headset on, now obviously I've struggled to keep the weight and the size of this down. That's the main problem with this. So it looks a bit ludicrous, but the guy that's going to wear it is not particularly bothered about what people think he looks like. You know, he's more interested about watching the football when it's on the other side of the field. He can't see anything. I think he can see the play when it's really close to him a little bit. I think he works on sound more than really on what it looks like. But using this, he can actually see the play on the other side of the screen. So I'm actually now looking. If I just stand up here, I'm looking out of the window, and I'm looking across the street, and there's a bungalow there, and it's actually quite easy to use. So I can actually look at that's another house. There's a railway line there. We may see some trains going by occasionally, and that's probably about I don't know, probably 50-60 metres away. So the length of a football field, and those trees over there in the distance are probably the length of the football field. So you'd certainly see the players running around, and you'd see those blobs, by the way, are just raindrops on the glass. Now I do have a hand control, and let me just pick that up. I can show you that's the hand control here, and you'll see that using the hand control, I've got these buttons here, and they allow me to. Hang on a minute, let me just tilt the. I see the camera down there. No, it's not so easy to use, but right, let me do that. There you go. So, using the handset here, there are 4 buttons, and I can do things like I can make it. So, for instance, I can make it go negative. Oh, hang on, I've got to switch it on first. I've got it on or a bit off. That's off, so that's on. That makes it go negative. So by doing that, it sometimes is easy to see things. You can see how the contrast changes when it's in negative. I can also I can freeze frame. So if I'm looking at something and I think, oh, I want to see what that is, I can do a freeze on it like that. And that means that I don't have to keep my head so steady, and I can just study the detail. So that's actually quite useful. I can also, if I'm doing things which are very contrasty, like text, if he needs to read a shop sign or something like that, he can actually press this control here, which is a sort of edge detection. It doesn't work terribly well on some subjects, but it works very well when you've got things like text and those types of things. And you can combine them as well. So if I operate the freeze like this, I can now put the edge detection on, and you can see how I can go negative as well. And it allows me to mix all those things together. The other thing I can do is I can actually zoom in on things. So if I, for instance, look at that window there, I can even freeze it and do this, is I can zoom in on that, which is just a sort of a pixel zoom. It's a digital zoom, if you like. So I've got instant digital zoom as well. So if I want to suddenly see really close, I can do that with the digital zoom, which is quite nice. Now I have got an analog zoom, but that's got some challenges, and I'm not going to demonstrate that at the moment. But that's all done with this wireless handset. So as you can see from the screen, I'm going to put this down there, but as you can see from the screen capture that I've got showing in the corner there, you can see everything that's happening from there. Now, what you were seeing there, the frame rate is actually much higher than that. The frame rate, which is you're seeing now on the screen here, is only, because this is VNC running over a Wi-Fi connection to the Raspberry Pi, you're only getting 1 or 2 frames per second. In the headset there, you're getting 30 frames per second, and the latency is almost, I mean, it's maybe 200 milliseconds, something like that. I've timed it at, so it's absolutely fine. You can move your head, and the Raspberry Pi 3 is an amazing little piece of kit. Works really well. But the nice feature of the Raspberry Pi is this VNC thing. So all I can see in the screen itself is actually these two images in my view. I've done it so that mechanically all you see is that part of the screen, so you don't see all of the other stuff around it, so it's not distracting. But the nice thing about having all the other stuff around it is that I can actually control the whole thing. If I click on here, if I do a queue, it should quit the program. Hang on a minute. If I go into, there we go. So I've now, this is the, have I got that right? No, in a minute, queue. Queue. There we go. So I've quit the application. So I can now, in here, I can go into Genie, which is a software programming editor, and from there I can, I'll show you very quickly, this is the actual code that does it all. So it's all written in Python. It uses the CV2 library, which you can see there, which is a fantastic open source video processing system. I'm also using Pygame, which is what I'm doing all of the game controller stuff with. So that's another really good piece of software. And the software itself is pretty compact, really. I've got connecting RS232 connection going on to the lens controller, which is the Arduino, and then this is all of the actual capturing of the images themselves and displaying them. This is all actually commented out. It's code I'm not using anymore. This is all the focusing controls. So it's just I mean, I'll take you to the very bottom of the program. You can see, so that is the entirety of the program. So all of the things that you've seen there, the split image, all of the button pressing. I've got a load of other buttons I can actually press as well whilst I'm tuning it for things like brightness and that sort of thing, and moving the images from left to right to get them aligned for his eyes, which I think I've got pretty much sorted now. So I've got a load of configuration things in there as well. The whole thing is 250 lines of code, and in fact half of that is actually commented out because it's code that I haven't sort of experimented with and needs cleaning up. So probably less than 150 lines of code, I'd say, to do all of that for the Raspberry Pi. The batteries are working fantastically. I've tested it. I've had over 4 hours running now on the batteries, which is great. I'm really pleased with that. The only thing I've got to implement on those is that when the batteries are running flat, I need it to shut the Raspberry Pi and the whole system down. At the moment it doesn't, so you can over discharge the batteries, which is not a good thing for lithium polymer batteries, but there's a UPS system in there which can do that. I just haven't wired it up yet. There's just so many elements, little tiny bits and pieces to this project, which makes it, it's gone on for a long time already, but to get all these things in place, so many little aspects to it. But I'm glad to say that the whole thing has really come together now, and is working really well. And all you need to do is switch it on. It boots up, it goes straight into the program. You put the headset on, you can see immediately. You turn it off, it goes off, it shuts itself down, and you don't corrupt any file or anything like that because the UPS system looks after it all. So hopefully tomorrow I'm going to take it to the guy's house, and we're going to have our first session with it, and hopefully later on he'll try it out at the football match, and it should, hopefully, fingers crossed, be an improvement over just listening to the game, which is what he does at the moment. Now, you know, I mean, I've been every day. I've spent a couple of hours just tweaking things, and slowly,
you can see the letter wrapped over.
Oh, you can, yeah. Would you normally be able to see the letter wrapped?
Oh no, my God, no.
So there's definitely you know, we're onto something. We've got something we can play with here, haven't we?
Yeah.
You say it's amazing, that's good.
It is, it's brilliant.
As I say, I don't know how you're going to feel after wearing it for a whole football match, but
Oh, I'll get used to it.
your neck will go. I tell you what, let me put something, a product out in your cupboard on the windowsill and see if you can read what
Right.
it says. That'd be good. Where do you keep your stuff in the cupboard? So here. Alright, let's try that then. I'm going to put that on the window. You tell me, see if you can see what that is.
What it is.
Yeah.
I'm trying to think what you got out of what cupboard then.
Yeah, I know. And you can
What
see
is
you're
it?
cheating.
Is it a product?
It's a
or-
product that you would buy.
Yeah. Is it cheap?
It is. Well done. There you go.
Yeah, but I was kind of.
Was that a educated guess?
I knew where the tea bags were.